Well, setting the expectations quite high. So did you enjoy the conference so far? Yeah, all right. So slightly different talk. So who we are, first of all. So I'm Renzo, this is Liam. Hello. We are both developers at Uswitch. Yes, we are hiring. There's a booth downstairs. Go have a look. Have a lovely chat with Lucas. And we do quite a bit of Clojure, so that's why today we have a Clojure talk, Clojure-related talk. We also host a few events like the Clojure Dojo or the Papers We Love meetups. So if you're interested in those things, there are a couple of links there, our GitHub account. If you want to see what kind of project we are open sourcing. And we also have nice articles on the labs uswitch.com. So what we're going to do today is a game, so it's just meant to be fun. We are going to make you questions about the language we all love, Clojure, and see if you know some of the very small nuances that there are in this language. And the idea is that we are going to give you answers that you don't expect. So that's fine. And the idea is also that we are going to learn from that. It's not, sometimes this is kind of code that you don't find in your everyday Clojure. So it's perfectly fine. But we are using this as an excuse to learn something new. So we are going to show you more or less what we are going to do in a second. We are going to challenge each other. I'm going to make a question. Liam or myself is going to try to answer. There are multiple options. And then we are going to try to see if any one of you in the audience wants to answer the same question. If you raise your hand, you get the microphone and you try to answer one of the possible options. And hopefully you also are able to give an answer, an explanation of why it is that answer and not another one. And we have a few t-shirts here for you. We are going to have 8 quizzes, so 8 t-shirts. Hopefully there is the right size for you. We have a mix, and we have a few larges and a few small, and so on. I think that's all. We can
okay.
We can start.
So the first puzzle is, what does this evaluate to?
All right. Okay, so at first, I know what that does. It takes the first thing of something, and it's strange. It looks like a syntax error there. You get two single quotes. Is that okay?
It's quote, quote, hello.
Oh, quote, hello. Yeah, okay, so can you give me some help?
Okay, so the options are the first single quote, the symbol quote, the first letter of hello as a car, or the first letter of hello as a string.
Interesting. So, so the quote sign, the symbol quote, so it's actually printing quote, the first letter as like \h or as a string. So I'm gonna try with number 3. So it's printing the first like letter of hello. So anyone wants to? Who was first? Probably there. Where is the microphone? Yeah. Oh no. There is.
Symbol quote, I think.
So it's going to
number 2.
Number two. The symbol quote.
Okay.
Do you know? Can you explain why?
I think it'll evaluate and return a list of quote hello and then give you quote out of it when you call first on it.
I think it's correct.
Okay.
But let's check.
The answer is the symbol quote.
Oh, I made. Oh, okay. Congratulations.
Yep.
Well.
Yeah.
I can do the.
So just to talk through the explanation quickly, the quote is a reader macro that just expands to the function quote. So we're quoting a quote, which means that the list here isn't evaluated. So as you can see, the type of this is just a list. And when we call first in a list, we obviously get the first element back from it. So we get the symbol quote. So correct answer.
Okay. Yeah, you're perfectly right. So, okay, you got me with that one, but...
Yeah. So some takeaways from that. Code is data in Clojure, and unevaluated expressions are lists, so we can call things like first on them.
Yeah, you got me with that one, but I want to see if you can answer what this evaluates to.
Okay. So we're defining a function, and then redefining it inside this block, and then calling the function again at the end. So we have some options for that.
Here's some option for you.
So the number 10, the number 42, a number between 0 and 99, or this range of numbers. So at first we define the function to just return 10, and I can see that inside this, with redefs, we're returning the argument. But then we call it again outside the scope of that with redefs. So I would have to say number 1, it returns the number 10.
Yeah, that might be like an immediate answer to that. Anyone has like an opinion or a different answer or wants to try? Ooh. Come on. Nobody? Yeah, it's kind of long. Okay, so shall we go for the answer? Are we sure nobody wants to try? Oh, got it. Okay.
So I'm going to go for number 3 then.
Number 3, a number between 0 and 99?
Yes.
And the answer is? Nice. Could you explain why?
Yeah, so it's going to be non-deterministic. So it's going to do run. And basically with redef has side effect of changing the function to printing one of the value in the range.
Yeah, it's
So
pretty
basically
much.
when you call 10, it's going to be one of them.
Yeah,
But
it's
you don't
pretty
know
much
which one.
pretty much what you said. Yes. So, let's explain. With redefs is changing the root of a variable, and in this case we have the function called number 10, all uppercase, but it's still a var pointing to a function, and it is temporarily doing this inside the block where with redef is. Then we take this with redefs and we put it in, like we execute this in parallel over multiple numbers, and each one of them is reading the root of that variable, swapping it, and then it wants to go back to that. Problem is when you run them all in parallel, each one of those threads is reading perhaps a temporary like value that another thread has put there. So when it's trying to put back the value that it thinks it was the root value is not, and so the last thread who wins puts back whatever value that thread picked up from the original range from 0 to 99. So essentially what you have is a random number generator, although like there are better way of doing this, but it works. It works that way. It works that way. So takeaway, with redefs should not be really used in parallel. I cannot think of like useful use cases of why you should do that. And the other problem is that you can have these with redefs in one place and then dig down the code. You have multiple function calls going inner, down, and then you have something like this happening. And you don't see the connection between the 2 points in the code because they might be far apart. So if you see a with redefs in production code, is very likely a smell, something you want to change because it might give you these kind of things as soon as you execute that code in a concurrent multiple threaded environment. So, and by the way, if you read the Clojure docs, it's all there in the with redefs definition. So it is specified.
Okay, so our next puzzle is, what happens if I type this at the repo?
All right. Get.
Okay.
No, wait.
Oh.
Let me read it. Let me read it. So we have a contains of like a vector of 2, 5, and 9, quite easy. And then is this vector containing a immensely huge number inside?
Okay.
Okay, returns true. It returns the number 9 because it's very big, I guess. So it's the last. It returns false. Yeah, looks likely. Or it throws an illegal argument exception value out of range for int. Oh, because that 4 billions blah, blah, blah is more than what an int can hold. That might be it. So we'll go for number 4. Anyone has a different, oh, we got somebody ready there. Let's see.
I think it's 3 because contains looks up the key and vectors are keyed on their index. So assuming it's not bigger than an int, or not bigger than a number that Clojure can handle, I think it's going to look at the index of that vector, which is going to be.
Okay, that was a good explanation. I think it deserved a t-shirt.
Yep.
Shall we see? And it returns true.
Yeah.
But I appreciate the effort, like in trying to guess.
Yeah.
So,
So to explain that, you're right. It doesn't check for the existence of this number. It checks for the key. This number is actually 2 to the power of 32, so it wasn't chosen randomly. It's beyond incapacity. To get the key, Clojure casts it to a number in Java and then calls int value on that. Int value truncates ints because when it overflows, it's basically the equivalent of doing mod 2 to the power of 32, so it returns 0. So this is included.
and since it's included, that's fantastic. And we have.
Yep.
Yeah, sorry, good way to take takeaways.
Yeah. So takeaways from this are, vectors with this amount of items, it's possible, but it's unlikely you're ever going to encounter that. It's a possible case of garbage in, garbage out, but it's maybe a bit unexpected. The function get suffers the same problem, so just be careful when the key isn't under your control.
Good lesson, good lesson. All right, so what this evaluates do?
Okay, so we have a map with 2 random integers, two strings. So let's see some options for it. It could create a map with 2 integer keys. It might not compile if the integer is too big. It doesn't compile because you can't use numbers as keys. And it doesn't compile because it throws a duplicate key exception. Well, you can definitely use integers as keys. And it's probably unlikely that those are going to result in the same number, so you wouldn't get a duplicate key. So maybe it's number 1. It creates a map.
Okay, so anyone has a different opinion? Or that guy over there, I think it was him. Yeah. White shirt.
I think it's 4.
4.
Because both those, it's code as data again. I think it's the functions of those keys.
You think that?
I think that the 2 functions are the keys, and because they're the same.
Okay, that's a good explanation.
Might not be.
That might be it. Shall we check? And that's true. Congratulations. Yeah, indeed. So, there is an implicit evaluation rules in Clojure, right? We go from left to right and from inner to outer to evaluate inner expressions in another expression. So we have these rules. But when reader literals are involved, there are exceptions to this rule. And one of them is when we try to read a map with the curly braces. That is a reader literal. And it's not just for maps, it's also for sets. Same thing. So what happens if you go dig down the code and so on and so forth in the reader is that the hash map object that is going to hold your keys and value is created before what is in like a literal expression is actually evaluated. In this case, random int is not evaluated at that point. So that is what generates the double key. So rand int and the other rand int are considered 2 lists that are used as keys inside the hash map. Yes?
So it's saying it looks like rand int 5, rand int 10, that wouldn't throw?
No, because it's not evaluated. So it will, I think there is, we have a few takeaways. So as I said, the evaluation, there is an exception to this rule with reader literals. And by the way, if you, what I wanted to say? Well, yes, by the way, if you can try, if you use hashmap as a function instead of the reader literal, that will work, and those randint will be evaluated. So you can try that, not with 2 to the power of 10, because that is over the integer range that will throw. But if you use it with 2 to the power of 4, which is a proper number, if you're lucky, this will go through. So you have 1 over 1,000 possibility that this is going wrong, right? No, 2,000, sorry, not 1. Yeah?
Okay, next puzzle. What does this evaluate to?
Okay, so we have depth of an expression. And that, again, single quote. So I know what that means is quoting that list. So that is not going to be evaluated as 2. I know that now. Then we are going to apply the first of that list, the symbol plus, to the rest of that list, 1, 1. All right, I know what this is.
Okay.
But, yeah, go ahead. Yeah. So legal argument exception. Don't know how to create ISEC from long. Oh, now it's confusing me. The symbol plus, the number 2, the number 1. Oh, I definitely think this is number 3. Anyone wants to try or give a different answer? With that?
I think it's 2.
The second answer?
This might be completely wrong, but I vaguely remember if you use a symbol as a function without it being evaluated as a proper S expression, it just acts as a function which returns itself, and somehow the plus is getting passed. Yeah, I'm not explaining terribly well.
Okay.
But I think you end up with the symbol plus rather than the function plus is what applied gets given, and then when it tries to use that as a function, it just returns the symbol plus.
Okay. That seems interesting explanation.
Okay. Should we see what?
Shall we see? Michael? And the right answer is the number 1 was the 4. But there's something true in what you said.
Yeah, so you were kind of halfway there with that answer. So the type of plus is the symbol. You can use symbols as functions, but what they do is they look themselves up in the collection that you pass as an argument, in the same way that you could use a keyword as a function. So if the argument isn't in a collection, we get no, unless we pass in a default, just as you can do with a keyword. So the second value is the default, which is the number 1. So you get number 1 returned.
Oh.
But it was a very good explanation. You're almost there. So yeah, symbols are functions. You can use them for collection lookups if you wanted to.
Interesting. Okay. All right, so we're going to puzzle number 6. There are 3 to go, right? So what this avoids to?
Okay, so we're sorting 2 vectors, and both of them have not a number in there somewhere. So not sure how that'll behave, so should we see the options? Okay, so it could throw an arithmetic exception. It could be false or true, or we could get not a number back. Maybe I'll go for arithmetic exception, because I'm not sure that you can sort not a number like that. So maybe it'll throw.
Yeah, that not a number is... Yeah? Anyone has different opinion or wants to try to answer this one? What do you think will happen with NaN in that? Do we like NaN? We don't. Yes, we do. Or we don't. I don't know. 1, 2. We got a try there. The microphone is coming.
Does it return false? Because the comparison, because this is a guess, but because Clojure can compare NaN with numbers, but it does so unstably in the underlying kind of comparison. So the behavior is unpredictable and it's based on the original order of the inputs.
I think it's an interesting answer. Shall we check what's the... And the right answer was false. So congratulations. You got it. I'll push it for you. I'm going to have all this more in a second. It's here. Oh, Steve. Thanks, John. True is false. False is true. Number 2. The explanation is a little more complicated than that. is not really that it is undeterministic. It is deterministic in the way it is done. So the problem is certainly the none, the not a number thing. And when you compare a not a number with another number, it doesn't matter what the number is, you always get that it is the same. So compare double none, so compare not a number with another number is always 0, which means they are the same. So of course, if you're trying to sort things, depending how you sort them, you can get unwanted results because it's comparing and it's always returning that are the same, of course. So it depends on the ordering, so that's true. But the problem is not exactly that, it's deeper than that. The problem is that Clojure is using the generic arrays sort of an object array because it doesn't know what the arguments are, not being a typed language, being a dynamically typed language, so it's using the most generic option. And the problem with that is that Java, not knowing that these are doubles, is not checking if there are not numbers in that array that you're passing to the function. And given the algorithm that Java is using, which is, I think, a merge sort with a twist, I don't remember exactly the name, is depending on the initial order of the collection, can return either false or true if there is can return a different collection or not based on the presence of a none. So what Java does is, if you have doubles, it gives you a double sort, and that will remove the not numbers from the collection, do the sorting, and put them back at the end. So if you try that, like using the proper function, it will work as expected. And you also see that your number from integers are becoming doubles because they are cast to doubles. So bonus, it also fails the same in Clojure script. But yeah, it's a bonus. Takeaways. So if floats, math operations are your thing, be aware of the none. So the none is going to hit you, not just in sorting, but in many other ways. So you always have to pay attention and filter them out if you're doing operations with doubles. And if you have to do that kind of operation specifically, use the specific Java sort for doubles.
Okay, next puzzle. What does this evaluate to?
Okay, so we have a local binding let of x and y. So x is 1000 and y is said to be the same as x. Are they identical? Yeah, but can you give me some option? The call never returns. Oh, that's creativity. True, x and y are identical indeed. False, x and y are not identical. Throws exception. I know, I guess I would go with the easy one. They should be the same. Anyone thinks differently? Antonio? Yeah, I saw him.
I think it returns false because Clojure boxes numbers. So we will never know that x is a long. You'd have to type hint the binding.
Yeah, it might be correct.
Yeah.
Shall we check? And the right answer to puzzle 7 is false. Congratulations. It might be a medium.
Yeah. Okay, so to talk through the explanation of that. Once identical is compiled down to the Java, you can see the signature here as object X, object Y. So as you correctly said, there need to be some auto-boxing of the long primitives. It's just the equivalent of calling that long constructor on it. So you get two objects. I heard someone whispering about caching. That Java does actually cache longs in the constructor, but only in this very specific range of -128 to +127. So you can see if we'd used the number 120 there, then it would have been true.
Oh, yeah.
So, and this actually returns true in Clojure script.
Okay, Clojure script got it right.
Yeah. So some takeaways of that. Clojure is built on Java, so remember that. Use equals for numbers. There's only very, very limited cases in which you'd actually want to use the function identical, so you could probably want to use something like equality operators.
Okay. Right, so last quiz, number 8. what this evaluates to.
Okay, so we define a function that increments a number, put it in a vector, then redefine the function so that we are multiplying the number by 100, and then calling the first item in the vector on the number 1.
So here are a few options.
So we have the number 2, if it had been incremented, the number 200, both of those were applied. But maybe I'll go for 100 because the function after we've defined it the second time is multiplying 1 by 100. So I'll go for the number 100.
All right, all right. Anyone has a different opinion? Okay.
I reckon it's going to return 2.
The number 2, sorry, or the second
number
answer?
1. I mean, number 1 is the correct
okay.
answer. It's going to return number 2, I believe, because my fn is bound to a vector that contains a function. The function is increment, okay? And that's what my fn contains. And then even though A, the global symbol, is redefined with the new function multiplied by 100, the first of my fn contains the value that was bound on line number 2, which is increment. So first of my fn will return the first function with the vector, which is increment, and it will apply that to 1, which is 2.
It sounds convincing. Let's see, let's see. And the right answer was, congratulations. It's large. There's still a few smalls here. Yeah, so, well, it's basically that was the right explanation. So I think I just want to grab your attention to the duality of vars. So vars are things that have a target, something that is pointed at, and the pointer itself, that this is what is pointing to the value. So with that difference in mind, if you try, for example, this is getting that function out back from the vector and printing it as a string, and you can see it's some like random string with numbers and stuff. And if we define that again and we print again the same variable, we see that that string of characters and stuff is changing. That means that every time we redefine a function, redefine a var in Clojure, if that var was already existing and so on, that the value that var was pointing at is completely replaced with something else, which is completely new. And since we were capturing that in the array, before doing the swapping of the var, we are just changing the pointer. We are not changing the value. The value was capturing the vector. So when we try to actually execute it, we're just getting whatever was the initial definition of the function. So take away, var are like pointers. They have that mechanism in place. And another thing that you might be tripped off sometimes at the REPL is that when you create a var like a def or a def, and you type it at the REPL, it's automatically dereferenced. You never see the var object. In order to see the var object, you need to call the var function or use the equivalent reader literal to extract the var, and then you see the var object. Yeah, I think that was all for us. A little bit of self-promotion. I'm writing a book that is pretty much related to like these inner nuances of Clojure about the standard library, and I have also a series of screencasts that are documenting some of these findings, and there's a nice discount code there if you want and you're interested in the book. Are there any questions for us?
Anybody with any questions, or have we burnt your brains out with those puzzles? I think
Come on, it was fun.
One back there.
Thanks for that. That was really fun. Do you have a favorite kind of fun fact or quirk about Clojure or ClojureScript that you learned in the process of, I guess, maybe writing your book?
What a good question. That's really nice. I'm thinking. So I think I found many of those myself. So other I collected while I found them on chats or user groups. So I think one fun fact, I think one fun fact was a few years ago already, was to go inside the Clojure sources to understand some of these things and see how some of those principles that we take for granted sometimes when we start programming, like use good names, use short functions, don't use too many parameters, all of those things are not used in the Clojure sources themselves. So how big and complicated things are in the Clojure sources was probably not, it was not a sad discovery. It was just, it's probably now I put that into, in the context, I understand that they are like they are because Clojure is a pragmatic language. It is just giving us a tool that we can use, and the nice face is on our side, while inside it might not be that nice. So that was my discovery. Liam, if you have anything, just feel free. I'm constantly talking, so I don't want to. Yeah.
Great, thank you very much. So a round of applause for Renzo and Liam. Thank you very much.